Hello, dear students. My name is Shashank Shekhar, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for KVPY 2018 SX stream, that is class 12. In this video, I have taken question from part 1. Let's see what the question is. The very second question of the paper. On any given arc of positive length on unit circle mod z equal to 1 in the complex plane, okay. Now four options are given. There need not be any root of unity. There lies exactly one root of unity. There are more than one but finitely many roots of unity. Option D, there are infinitely many roots of unity. Now what are roots of unity? Let's see how can we observe the correct option. How can you find the correct option? So the roots of unity, considering roots of unity, uh, thinking about roots of unity, the roots of unity means the roots of the equation z raised to power n equal to 1. Now 1 can be written as e raised to power iota 2k pi cos 2k pi plus iota sin 2k pi. Cos 2k pi is 1 and sin 2k pi is 0. K is some integer. So finally the roots of unity means z is equal to e raised to power iota 2k pi by n, where generally k is taken from 0 to n minus 1. Finally z is basically 1 e raised to power iota 2 pi by n e raised to power iota 4 pi by n and so on. These are the roots of unity. Clear? Now on this circle, this is a circle, unit circle. I am plotting this circle. Okay, centered at origin, radius 1. So on this circle, if some given arc, on any given arc of positive length, suppose I take this arc here, this arc length is given. On this arc length, now these roots of unity are distributed symmetrically on this circle. Each distance between two consecutive roots, the chord joining two consecutive roots will actually subtends what angle? 2 pi by n at center. Now considering, let the given arc to be L and that arc is making some angle, suppose theta at the center. So here we can say as a radius is 1, r is equal to L, L is equal to r into theta, r is 1, so it is equal to theta. We can say this implies theta is equal to L as r is equal to 1. Clear? Now if we take suppose 2 pi by n to be smaller than this angle theta, this angle 2 pi by n is smaller than this, in fact this angle which this arc length subtends at origin, and theta is basically L here. That is, I want to say, if you choose n as something greater than 2 pi by L, L is given, so n is anything greater than 2 pi by L, for any n there will be a root which will lie on the arc, that particular arc taken. So for any n belonging to the interval 2 pi by L to infinity, n is integer, natural number. Okay, so for any n belonging to 2 pi by L to infinity, the root of unity, this root will fall on this arc, particularly this arc taken. For example, if suppose L is very small, suppose I'm taking it is as 0.01, suppose, okay, or any L you can take 0.001, 0.00001. So corresponding to every L, n, if I take n to be more than 200 pi, that is, you can take n greater than or equal to 200 pi means 3.6.28, greater than 628, that is 629 to infinity, you'll get a root of unity falling on that arc of length 0.001. So the answer to this question must be, there are infinitely many values, that is infinitely many values of n possible. So correspondingly, infinitely many roots of unity will fall. For n equal to 629, the root of unity will fall in this on this arc taken. For n equal to 630, for n equal to 631, corresponding to the arc length given to be 0.01. Similarly, for any given arc length, there would be infinitely many values of n, corresponding to which the roots of unity will fall upon this taken arc. So the answer to this question must be, there must be infinitely many roots of unity. See, the roots of unity are basically symmetrically distributed on this circle. So if you take any arc, we can increase n correspondingly. So for for any arc length, given arc length L, we have to take n greater than 2 pi by L. Any n in the falling in the interval 2 pi by L to infinity. So infinitely many values of n and corresponding infinitely many roots of unity will fall upon that. I hope you understood the solution, and thank you for watching. Stay tuned for the next question. Thank you.